we're not alone on the planet. We sometimes think that we are, but that's because we are human-centric and we separate ourselves from the natural environments that have really given us so much without asking for a lot in return. And I think if we are going to be able to survive on this planet, we have to get closer to that harmony. We have to get in better lockstep with the natural world.
And so nature has been solving these problems with functions and mechanics and chemistry for 3.8 billion years. It's a lot of research and testing and trial and error in the evolutionary process to design something as elegant as a bird in flight.
Welcome to Future Perfect Tech. We're here today with Shana Longo, ex-AAS Technology Manager at Legrand. And if you don't know what that means, like I didn't, it's Anything as a Service Technology Manager, which is a fantastic new way to describe all the great things going on in that world. And we're also here today with Nick Heier, Business Development and Innovation Management Consultant. Shana and Nick have something rather unusual in common, a passion for biomimicry. We'll dive into it a little bit deeper in our talk today, but for listeners who may not know, and I certainly didn't know until I was introduced to Shana, biomimicry is a design process that takes patterns and innovations in nature and applies them to product design, architecture, and technology.
Welcome to Future Perfect Tech, a webinar and podcast series by Harbor Research. Each month, we'll be having discussions with the leading experts in smart systems and the Internet of Things on innovations in markets, technologies, and ecosystems that are working together to build a better future.
I do believe in the strange way I'm sold. Do we have the models
Shana and Nick, thanks so much for joining us today. Let's start off with a quick round of introductions, and I'm sure as well everybody would love to know how you both got drawn to biomimicry as a field of research in the first place.
Great. Thank you so much, Owen. So I stumbled upon biomimicry as a recovering sustainability professional, and I characterize it as that as I spent 6 years in a corporate sustainability role, really doing a variety of things to impact our resource usage, really define our high-performance building strategy, and look really critically at our government affairs and relations. And I knew I wanted a science degree to back up my experience and my undergrad. And I found this program, really stumbled upon it at Arizona State University, and it really intrigued my interest. And I originally thought that it was a spin-off of biophilia, and I thought it only talked to the design world. But I came to really understand that it's this nexus of engineering, design, and really just taking full-on inspiration from the natural world. And I've always thought of myself as someone who feels a lot of energy from the natural world. So this program was just super interesting to me because I wanted to be able to start applying natural elements to the things that I do every day. And I think it has a very broad spectrum of opportunity associated with biomimicry that enables really anyone to practice biomimicry.
Fantastic. And you just mentioned something there, biophilia. That's another term I'm not familiar with. What is that?
So biophilia really means the love of, I think, life. And it's incorporating natural elements for the love of nature, as opposed to living in harmony, which biomimicry is much more focused on the balance between humans and nature. Biophilia examples and biophilic design include things like incorporating natural colors into built spaces or bringing in plants and living walls into indoor environments or water features. So biomimicry takes it really far beyond that, I think, and applies the strategy and the functions of nature to the human world.
Wonderful. Wonderful. Another thing I learned today. Nick, what about yourself? What's your background and how did you get drawn to this field?
Yeah, thanks, Owen. So I spent 20 years in the Marine Corps. I joined right around 9/11 timeframe. And as I was getting ready to exit the Marine Corps and retire, I realized, okay, I'm at this sort of crux of what am I going to do? And I just spent 20 years in service to my country, but now I have an identity crisis. And it became really important to me when I was asking those deep questions that I needed to have this sense of creation, because so much about serving in the military, and especially during wartime, is a lot of destruction. And so I wanted to create something. I want to be part of creative processes. And so then I asked myself, well, what do I want to create? And I came up with this sort of idea that what I wanted to do is I wanted to create systems that encourage us to have a better relationship with our environment. And that was really important to me. So now I have a purpose. I have a methodology. I've got this idea. So now what do I do? And I was like, all right, I don't know, landscape designer, architect. All those things actually take a lot more time. Like an architect is like an 8-year detour, and I've got a family to feed. So, and I was a business undergrad. And then I found biomimicry in the program at Arizona State, and I started looking into it, and probably spent a good 2 weeks on chasing the biomimicry rabbit hole. And it was just really profound. And there was nothing, I just knew that was it. This was everything that I wanted to do. This is me being creative. This is me creating things that are useful. This is a purpose, and it's all about, in biomimicry itself, it's all about creating conditions conducive to life. So it really matched up well.
That's a very inspirational story. In fact, both of you have just started off with very inspirational stories. Perhaps you could help us to understand a little bit more of the differences in some of the terminology that you've brought into the conversation. We talked about biomimicry, biomimetics. How can we understand this a little bit better, particularly for somebody who hasn't encountered this before at all in their lives?
For me, biomimicry is being able to take lessons from nature and incorporate them into a design process or a problem-solving process. And we often refer to it as biomimicry thinking as the process. And then the biomimetics is the output. It's the solution that is mimicking something in nature. And when we participate in or we host biomimicry, it's a very multi-stakeholder, involved process, interdisciplinary, that allows you to critically break down a problem and really brainstorm outside of the normal box. We are surrounded every day by so many resources and so much knowledge that has been here for so long that we take for granted. We walk down the street and we don't think about the shapes of trees and how it helps mitigate water, or the strength of branches and how we could apply that to the strength of our buildings, or even more conceptual strengths within organizational planning or things like that. And then I think the biomimetic side of things is, how did you take that biomimicry thinking experience and really tie it to something that achieves a measure of success for human and all living kind, that isn't just operating in a vacuum, but doesn't have hazardous outputs or negative externalities that could not be a benefit to the rest of the world.
I think that's a really good definition and explanation of what it is when we practice biomimicry. And it starts with asking nature. So everything biomimicry in our process begins with, how would nature do whatever? And then that whatever is a function. And so that kind of, when you're talking about biomimicry in particular, what you're talking about is the conscious emulation of nature in order to produce conditions that are conducive to life, because that's what nature just naturally does, is sustain life. And those elements, that's what really distinguishes biomimicry from any other sort of bio-XX whatever, like biophilia, where Shana was saying earlier. Biophilia is really about the form and representing the form of nature, because it reminds you of how much you love being in the natural environment. But it doesn't necessarily ask what the function is of that form. So in a biophilic design, you might have a lot of green, or you might have things that are plant-shaped, organic shapes instead of straight, rigid lines and 90-degree angles. But nature uses those sort of patterns for a reason. There's a reason why the leaf is shaped this way. And sometimes that reason comes down to resource efficiency. Nature is always optimizing resources. And so that is the mindset that we approach when we ask nature for inspiration and then try to figure out how to emulate. And the end result is that everything is producing conditions conducive to life. So you're not going to have toxic chemicals in your process. You're going to have really healthy chemistry instead. You're not going to be wasteful or even produce waste. You're going to figure out how to close the waste stream off and make use of the waste, or at least build another cooperative relationship where somebody else can use the waste. And that sort of systematic approach to it is really what breaks it apart from, say, biophilia, which is form alone, biomimetics, a sort of technical application of something that nature is doing, very functional approach, but not necessarily a holistic approach, and the other sort of bio-XX genre of things that are cool about nature.
That was extremely helpful. I in many ways, it kind of reminds me of my first encounter with design thinking, as opposed to traditional kind of more design discipline. And is there any relationship between design thinking and biomimicry or biomimetrics?
So design thinking, I absolutely love the design thinking concept because it takes your empathy gathering, your insight gathering from actual humans who have problems to solve. And I've been through many design thinking processes where we actually collected data right on the street from folks to solve problems, because people will candidly give you information, and then the design thinking process is really extracting what's important out of that to really drive the solution they may or may not be explicitly asking for. And I love those elements of the problem that you think you're solving may not always be the problem that you should be solving. And when it comes to biomimicry, it's a very similar design thinking process. Typically, they're both circular in that, you make your way through the steps. Steps might not occur in like logical order all the time. But then at the end, you always have the opportunity to circle back around and say, did what the approach we take really solve the problem that we thought we were trying to solve? But when it comes to biomimicry, instead of relying on empathy gathering and insights from humans, you're looking to the natural world. You're looking for biological champions. You're looking for function process systems that exist every day, all the time, and function. And as Nick has said a few times, that do create conditions conducive to life. So your resource is a bit different in the biomimicry process, but you're still wading through and ensuring that the problem that you're trying to solve is the true problem that exists, and you're using different inputs to determine that.
So when you ask about a design process, and Shana talked briefly about the biomimicry thinking process, which is kind of in the practice of biomimicry is how we frame, is our framework for a design process itself. So one of the things that's really important about understanding the breakout, though, is as Shana was saying, we are including nature and the sense of place and the biome into the design. And so it's user-centric in terms of abstracting a function, but like, what does this thing need to do? Or what does this service need to provide? But it's also nature-centric in terms of, well, we'll ask nature, how did you solve for this problem? Because everything on Earth is kind of subject to the same operating conditions anyway. Like, we all have gravity. We all have limits on resources. We all have, water is a big deal here on Earth, and oxygen. And the constantly changing environment. These are the basic premise of how things just function on planet Earth. And so nature has been solving these problems with functions and mechanics and chemistry for 3.8 billion years. It's a lot of research and testing and trial and error in the evolutionary process to design something as elegant as a bird in flight.
Fantastic. I think that's given us such a good introduction to these ideas. What about if we went and looked at some actual examples? Shana, do you want to start off with some of your favorite examples to maybe make this even more tangible than what you've just described?
Sure, I'll show you two that I really think about constantly because of just how they are such an engineering marvel. The first one is the Japanese bullet train. This is one of my absolute favorites. I think there's so many added benefits of having high-speed rail within countries and being able to mass move people. I think it has a sustainability play when you're cutting down transit waste. And the Japanese bullet train is actually modeled off of the beak of the kingfisher. So the kingfisher is this bird that they have this very pointed beak, and they move from a very low density area to a very high density area very fast. So when they fish for food, they dive into water to capture that food. And in that process, they're able to move very quickly from these different mediums. And when the bullet train was first being designed, it was encountering a lot of issues because it had to go through tunnels. And the shape of the, like if you think of a traditional train, it's very boxy. It has kind of an aggressive front where it's just not going to slice very easily through any kind of medium. And the bullet train is designed with basically a beak in the front. And the reason for that is when they first prototyped it, it was causing issues where it was creating this big boom because of the move from different densities. It was pushing air out of these tunnels and creating this loud noise that could be heard for miles. And it was negatively impacting the surrounding environment as well as the people. Then they reconceptualized it after observing this bird, and they narrowed and pointed the front of the train to allow it to better move through those density changes. And I think that that's just a phenomenal example of how we are innovative and future looking as humans, but nature has all these different ideas of how to do that. And we can apply them to even the most technologically advanced technologies. And it's not just limited to, you know, the trees or the greens or the basic things that we associate with nature. The other one that I've been looking to a lot recently is an organization called Meadowmark Innovations, and they were born out of the Harvard's Wyss Institute, which is an organization that focuses on biomimetic technologies and bringing them to market. So they work very targetedly at identifying valuable research that has the potential to be turned into a commercialized project and tying those scientists or those academic people into an entrepreneurial kind of collection of folks that are interested in developing startups. So Meadowmark Innovations has developed a technology that is actually it's a catalyst that's based off of the matrixed structure of blue butterflies. So when you see blue butterflies in the wild, even when you see orange butterflies in the wild, a lot of that color is actually coming from structure as opposed to pigmentation. Nature does color really well, and it's typically a reflection of light or a refraction of other particles. And how we perceive color is actually not how we use it in the human world, which is typically through dyes and chemicals. And so this organization, Meadowmark Innovations, is really trying to take on the catalytic converter and the electrolyzer industries to say that there's a better way to produce these products that help us clean our air and manage pollution and have great implications for smarter, cleaner cities that is more based on how nature does it, is more natural, uses less materials, is more sustainable and more efficient. So those are the two that right now are always on my mind as these just technical marvels that were built off of something from nature.
Nick, what are your favorite examples?
I guess probably the one that I like the most or I use the most is the carbon capture technology for making cement, which one of the early champions of this is this professor, Brent Constance. He was a Stanford professor. He understood that coral is making everything in the coral reef through this process of making lime, right? So they're making limestone, calcium carbonate, and they're getting it all from their environment in the ocean at ambient temperatures without having to beat it down or break it apart or chemically cure it, no additives or anything. Coral are just sitting there constantly producing the second most used commodity on planet Earth behind water. And that's cement. And so he thought, well, how do I do this? Why can't we do this? Why do we have to go through all this process of quarrying limestone and breaking it down and then mixing it with all the different aggregates, et cetera? So he did. And he came up with Calera in about like 2007, I think. So Calera did carbon recapture from power plants, like the fuel burning electricity plants. You would attach this carbon capture technology to it. And it would then abstract all the carbon, mix it with calcium ions at ambient temperatures in like an ion bath, and come out with calcium carbonate at the end, which he could then make into cement. So they went through a couple different rounds, and now I think the company exists as Blue Planet. But everything about that, as we're building and expanding the built environment, I mean, that just makes sense. Why are we digging for rocks out of the earth when we already are producing carbon dioxide and we have everything ready on hand to just make it local? And PS is a lot more sustainable to just do it locally, attach it to a power plant, than to have to ship it anywhere. Cement's extremely heavy. So I think that's a great technology. Hands down, one of my favorites.
So where did all of this originate? What are the origins of biomimicry and bioinnovation?
Okay, so the question about biomimicry and biomimetics and bio-X goes back to this really, I gotta give her a lot of credit, and a really brilliant thinker and just a person with a lot of just drive to make this happen. That goes back to Janine Benyus. He wrote this book called Biomimicry. It was published in 1997. And since then, she's given, TED Talks and helped co-found first the Biomimicry Guild. Then she co-founded with Dana Baumeister, who is she's the program director. Shana, I think she's the chair, right, at Arizona State for the Biomimicry Master's Program. And together, once they met, they co-founded Biomimicry 3.8. That's where the pulse of biomimicry is this consulting agency, Biomimicry 3.8. And they are the ones that are, like how Lockheed sponsors engineering programs here in the University of Colorado system. Like Biomimicry 3.8 is that to the biomimicry program in Arizona State. And all of the materials that we have and the biomimicry thinking process, the life's principles, like those frameworks and concepts, they are produced out of Biomimicry 3.8, that organization, and generally used for when they consult with these large they consult with all sorts of organizations across the globe, but when they consult on a project for an organization like Nike, that these are the tools in the toolkit that they bring with them. So it's hard to talk about what is biomimicry without explicitly referencing Janine, her book, and the other co-founder, Dr. Dana Baumeister.
That's amazing. And as I'm listening to both of you talk about this, I just realized that we've probably been looking at these kind of examples without even realizing that they're coming really from nature. One of my favorite business books of all time, I don't know, this must be more than 10, maybe even 15 years old now, The Starfish and the Spider. I think about how organizational design is can be different, and that it doesn't always have to be so centralized, and how the starfish, right, as an example, is essentially as a decentralized neural system. And so it's perfect for regeneration, et cetera. And this book then applied it to organizational design. Why can't organizations be more decentralized? And lo and behold, we get things like, Skype and peer-to-peer networks like Napster and so on and so forth. It's, basically the internet has all been modeled, I think, on something similar. What about applying nature to organizational design in that way? Are there some good examples that you've come across in your study?
Oh yes, I like I said, I have a business undergrad, and when I came to biomimicry, I approached it as a business student, not as an engineer. And so organizational management, forming teams, all this sort of stuff. This is really what I've been doing, managing and dealing with people and trying to get us to achieve a common goal for 20 years. And so this aspect of it is really fascinating to me, and probably one of the coolest ones that usually comes up when you start talking biomimicry and organizations is the ant, and the idea of the superorganism, this organism that is so completely altruistic, like 1,000 out of 1,000% altruism, that they can't even fathom the idea that there is an individual. They're all just operating as one organism in complete eusociality. And the thought leader behind so much of that research is a Harvard biologist, E.O. Wilson. And he has this entire body of phenomenal work of just studying ants and coming up with an entire field called Sociobiology, which looks at like the evolutionary biology and to try and explain what are the pre-adaptations that influence the way that our social systems evolve. And what's really cool is when you start listening to E.O. Wilson talk, he'll explain why the ants are such a marvel, and wouldn't it be nice is always the thing that comes up in everyone's head. And then he'll say, but don't be the ant. We can't be the ant. It would be terrible. The society would just fall apart because we aren't eusocial insects. The things that existed in our evolutionary history are different. Eusociality in insect colonies that allow for superorganizations begins with a strongly defensible nest. It begins with having an abundance of food that you can just go out and eat, and the ant has that right by they forage. There's no need for them to even come up with brains to invent. It's all just right there, and they can just walk to it every day. And no matter how big the colony gets, like there's always going to be more for the ant. And humans, on the other hand, we had to hunt and gather, and then we learned how to cooperate and to trust one another and build tribes and hunt bigger things, and found our niche in our ecosystem that way. And then we had opposable thumbs, and then we had these remarkable brains and capacity for thought and invention. And it's just, when you look at it from that sort of deep thinking lens, you can see how you can obviously, there's lessons that you can take about how does an ant construct its colony, and what are the ways that ants work together, and are there ways that we can abstract that and adapt it for a human organization? 100%, absolutely. But you also have to remember that in nature, like, you are a primate with opposable thumbs and a really big brain, and individuality and eusociality, like there's going to be some trade-offs there. So you have to, in order to make it work, you're going to have to ask yourself a little bit more about the human as the user as well, not just the ant.
And Shana, when I was listening to you speak, and in particular when actually both of you were talking about how nature is so much better than humans are at conserving resources and creating circular systems that have a use for everything and don't throw off waste. How, it just strikes me that biomimicry could be a big part of our goal towards more sustainability. Is that the case? Is biomimicry perhaps a way to address issues like climate change?
I definitely think biomimicry has the ability to help us address climate change. I think sometimes we have a lot of these terms that are available in the market that really, they get to this idea that we have to do better, right? Whether it's sustainability, biomimicry, corporate social responsibility, environmental health and safety, we have all these buckets of terminology that really just seeks to me, it's a loud signal that humans feel disconnected from the planet, and we need to be driving better connectivity to our roots. And we all came from nature. Before we built buildings and we built cities and we built cars, before all those things were here with us, we lived near trees and by the ocean and in huts. And it was a lot more basic. And I'm not saying we need to go back there, but I do think that our attempts at starting to incorporate sustainability, biomimicry, all these different but relatable concepts into our corporate goals or our personal goals, or our organizational goals, anything like that we are trying to bridge that gap, is because we come from nature and we want to get closer and back there. I think where we sometimes have a challenge is we have this very human-centric view of how the world needs to work. And I mentioned this earlier too, and to me, biomimicry is really focused on harmony. It's about building harmony with the planet, because we're not alone on the planet. We sometimes think that we are, but that's because we are human-centric and we separate ourselves from the natural environments that have really given us so much without asking for a lot in return. And I think if we are going to be able to survive on this planet, and one of the key proponents that we talk about in biomimicry is really how nature has evolved to survive over time, or even how nature has adapted to changing conditions and disturbances that happen in the world. If we're really going to be able to do that, we have to get closer to that harmony. We have to get in better lockstep with the natural world. When we talk about sustainability goals, a lot of the times it's very focused on doing less bad, but then you have very ambitious standards like the Sustainable Development Goals, or even the Living Future Institute's Living Building Challenge. That's a building rating system that's incredibly ambitious. There's not many buildings that are certified to it in the world, but it flips that less bad on its head and says, what does good look like? What does better look like? And how can we do all of that while still maintaining the lifestyle that we're so accustomed to today?
I'm so glad you brought up buildings, because we spent a lot of time at Harbor researching smart buildings, intelligent buildings, and the technologies that go to make them so. Is there a way to apply biomimicry in a more concentrated fashion, and specifically to the technologies that are going into these buildings?
Definitely. I think that there's really two areas here that are they're bigger concepts to the building environment. And one is networks and the other is signals. And we typically think of the built environment as standalone individual places that we go to, may or may not be connected or smart or digitalized or anything like that. We think of them as these places that are built from all these different materials from all over the world, with which we don't typically have a lot of knowledge about where they came from. But I think when nature builds structure, and I'm using structure as kind of like a one-for-one for building here, because nature doesn't really build four walls, but nature does build structure a lot. And a lot of that time, those structures are based on stimuli and sensors and signals coming from the environment, as well as networks. So the example that I'll throw out there is what we often refer to as the Wood Wide Web, and it's a play on World Wide Web. And that is because trees have interconnected root systems underground that act as networks to communicate to each other. And this is incredibly powerful. The networks are integrated with fungi that are enabled to send signals through those networks to warn the trees of disturbances, to tell them when there's food available, to really just build this comprehensive communication system that we can translate to the built environment. So when we talk about the future of digitalized, IoT-enabled smart buildings, and we're looking at these simplistic kind of networks that we've developed to date, the question that comes to my mind is, how could we model our networks off of tree communication networks? What benefits are they getting from a sensor and environmental metric setup that we could internalize into our smart buildings, therefore driving down resource use or right-sizing them to specific spatial needs and not over-designing or creating excess space? How do we outline the necessary amenities that people expect to be in these smart buildings based on what their ongoing needs are? I think that there's a lot of different things we can take from forests that do this all the time and apply them to our built environment.
Fascinating. And I actually have encountered these these plants. Basically, I've got them growing in my garden. I was trying to dig one out, and I discovered it's connected to all of the other similar plants with the same root system.
Yeah.
Unbelievable.
Yep.
Nick, I can't resist asking you about how biomimicry might be almost at the polar opposite of the last 20 years you spent in the military. I mean, you mentioned it yourself that oftentimes war and everything to do with the military has to do with destruction, and now you want to be involved in constructing something. Is that at a polar opposite, or is it perhaps the case that the military has things to learn from biomimicry?
Oh yeah, I think Janine Benyus talks about like her frustrations with who was asking nature in the early sort of biomimetics space. You know, when she was coming up with the whole idea and translating it into action. And the answer was the military. Like, of course. But we had, the bombers is a really good one. And that's a classic sort of post-World War scenario of things that was going on, and where scientists were finding solutions in nature that the market was rewarding enough to be able to sustain the practice of asking nature. So she had this moment of crisis. And when I hear her talk about it in different like videos and interviews and stuff, it really resonates with me, because she experienced the same thing. It's like, well, if the military are the only people that are making this practice sustainable, what is going on? Like, we got to do something about this, because nature has a lot more to offer than how to, more efficiently deliver bombs. Now, the military, you would be surprised, actually has a huge amount of, everything from resiliency studies to environmental impact studies. Like the military, because what the military is that I think a lot of people don't understand, is a massive enterprise, right? It's Eisenhower's industrial complex. It's an entire industry of its own. And that means that there's a lot of people thinking and working and just doing things, living lives inside of this sort of enterprise ecosystem. And part of that is taking care of the larger environment. So there's a project ongoing that they are working with the Army Corps of Engineers to look at resiliency in coastal infrastructure and ask nature, like, how does nature design this? Everything from the mangroves to things that are more local in our southeast and southeastern seaboard and the Gulf of Mexico. And so that's a really awesome project that's ongoing right now. Engineering with Nature, I think it's called. And so there's military dollars and military people that are on that. There was a graduate student at Arizona State that was a little bit, I think she was a cohort or two ahead of me, and she is an Army National Guard officer, and she did her thesis project all on applying biomimicry to ecosystem preservation in training areas, which is, for anybody in the military, like, that's a huge pain point, is ecosystem preservation in training areas, because all training has to stop if there's an endangered tortoise. So rather than being so interruptive, where we have these sort of friction-based relationships between the soldier and the tortoise, how do we better design the training area and the processes around it to make that relationship more conducive? So there are a lot of things in sort of that system lens. As far as like the actual technology space, definitely there's plenty of room, and there's things that are going on. But you have to look at, when you're talking about biomimicry and you're talking about defense innovation, what Department of Defense usually wants in its innovation is something that's already kind of at least like kitchen ready. Like, you can demo it, and then we can talk about how we can adapt it a little bit and make it totally marketable for military needs. But that technology has to be there. The Department of Defense generally is not involved in the space of like 10-year innovation. However, there are organizations that have been doing it for a long time, like DARPA. And DARPA has some really cool technologies itself in their entire, I think Shana mentioned an adjacent thing, but they're living systems engineering long-range projects. And what's cool about this is like in the interim, in the short term, they look at things like how do we make a building that can self-heal, just the same way that nature self-heals its structures. And they're coming up with some really great stuff there in that space. But when you look at their long-range, sort of really audacious 10-year objectives, they're saying, how does nature build at the molecular level, the intracellular level, to make like a cell wall in a plant? And they're looking at the genetic coding for it and trying to abstract that information scientifically to say, okay, yep, here's the actual design parameters of this plant cell, and then apply that to structural engineering. So imagine that. Imagine, we've been designing post and lintel since the advent of the hammer and wood joints. And now these researchers in this biomimicry space are looking at nature on the genetic level and saying, oh, here's blueprints. So think about how those structures are going to change in the next 100 years when we start really looking and asking nature, how does nature construct a building or a structure?
So I want to hit on something that Nick said that I think we need to explicitly state about what biomimicry is and what it isn't. And we've referred to it a few different times, but it's really focused on the abstracting of something from nature. So it's not the same as bioutilization. And I think Nick gave a really great example of looking at the blueprints of like DNA from nature, plant matter and cell matter, and saying, okay, how can we abstract this into the human world? So it's not a one-for-one. We're not saying we're going to do it exactly like that. It's a mimicry, right? And those are key words to really understand how this practice works. I think often we get posed the question of, oh, is this an example of biomimicry or is it bioutilization? And if it's taking something from nature without giving a whole lot back or participating in a balance, then it's bioutilization. And bioutilization has negative consequences like overuse of resources or negative externalities, versus biomimicry, which is how do I boil this down to something that translates to the human world? Maybe I do use something natural. Maybe I do use, super basic carbohydrates. Maybe I introduce some, simple chemical reactions that are found in nature. Maybe it is still chemistry based, but it's done in a manner that is not taking from the planet. It's really creating that harmony again.
Janine Benyus begins her book, Biomimicry, right away going to Wes Jackson and Land Institute. And he has this decades-long, awesome operation going on out there in Kansas that is this polyculture sort of agricultural approach that it is completely organic, sustainable, doesn't use pesticides at all, right? And so that's one of the first examples in the book. And so people read the book and then come to the program and start learning about biomimicry, and they immediately want to throw permaculture out as like, well, this is a case that exhibits life's principles. It's like, okay, yes, but what is exhibiting the life's principle? Are you talking about the bioutilization of like an aquaponics sort of like using fish to help fertilize plants? Or are you talking about the systematic design? Because that's what's kind of different between biomimicry and bioutilization and how they kind of fold together. Like you can still use nature, spent a lot of time inventing the plant, so you can still use the plant, but the human design aspect is not the plant. You can't take credit for how the plant interacts with other plants.
Well, that seems to be a very important distinction, particularly when we want to start talking about sustainability and sustainable technology. And so now that we've got a better understanding of the terminology and the concepts, how do we translate bio-inspired innovation into smart products and services? And even more crucially, and it's kind of alarming that I've been asking this question, but how can we leverage biomimicry to move beyond the extractive industries and create a more sustainable environment for the human existence?
I think when we think of technology, we think of tangible products that interact with like a technological system. And when it comes to what nature does that's, I think, technologically advanced, is it really focuses on how everything needs to be a part of the system. It needs to work together. It needs to respond to signals. It needs to respond to stimuli. It needs to understand it's subject to conditions. And I think that's where when we translate some of these things to our world, we still have that human-centric approach that prevents some of those considerations that would allow us to not have to continuously reassess what sustainability is or what we need to do to be more sustainable. I think there needs to be a worldview change. And I've seen a few different cases where organizations are starting to bring in a biomimicry specialist, or they're starting to expand their circular economy programs to focus on incorporation of natural elements. I've also seen design thinking consultancy firms translate to biomimicry consultancy firms. I think there's tons of resources out there that'll help drive the change of viewpoint, but there's also a hesitancy to do that because we are a dominant species and we do want to maintain that dominance. So I think there's ways that having conversations like this, talking about how technological innovations like the bullet train, that wasn't at the expense of humanity. And that's not like at all the kind of picture we're trying to paint here. It's that you can take these advancements, these ideas, these really applicable, unique things about nature, and you can apply them to very high-tech things that benefit humans. But I don't think enough people understand that connection. There's a lot of work being done in robotics that are mirroring or trying to mimic some of the natural elements. That crosses the line a little bit. It's not full biomimicry because sometimes the ethics of developing those things aren't there. And Nick alluded to it too, is sometimes those things are done for military purposes. And biomimicry thinking, really, you have to have the ethics incorporated as well. It's not, you don't just do it for the sake of producing. So I think there are, again, unique technological advancements like robotics, like material science, that have we have really large potentials to learn from nature. Sometimes it's the application that challenges how close it is to biomimicry, because if we're not using it for the right reasons, then it is putting us at odds with the natural world.
The ethos is extremely important. It's at the center point of what it is to do biomimicry. That one sort of what makes biomimicry different from everything else in the market is really the ethos. And if you aren't ready to approach those ethics and see how they translate for your organization or your project, then you might not be ready to be asking nature how to do something. Oh, and you began this question by asking about, as technology advances, maybe we can get past the use of fossil fuel, but in exchange to have these super efficient conductors, we need to get these other precious metals out of the ground. And what's going to happen then? We're still just ripping up the earth to pull out these metals. So there's kind of two things that I'll pitch your way. One is at the nano level, where a lot of this technology, especially where Shana was talking about materials, the research right now is being done at the nano level. And how does nature solve for function, whatever? A lot of times nature's solution, because nature builds from the bottom up, it occurs at the nano level. Like any product that's using the lotus effect, that's because at the micro and nano levels, there are these little bumps and ridges that create a super hydrophilic surface that allows water to just beat up and slide right off. What about the shark skin antimicrobial surfaces? Like, again, the shark skin at that microbial level, right, where the microbes sit, it's got these nanostructures that prohibit them from being able to stay on that surface. And so then, because nature arranges in those sort of building blocks from the bottom up, it can have these really elaborate structures. But, it also takes nature 12 months to gestate a gray whale. So we don't always have that luxury, so to speak. We're not speaking in that sort of, the human life cycle is less than 100 years. And then the other thing is kind of a conceptual piece of it. And when we approach our resource use in particular, that we approach it with, right now, it's abstractive, and we take out, and then we make something with it, and then we throw that thing away. And it doesn't, it's not lost from planet Earth. Well, in some cases it is. We shoot it into outer space and it sits there and collides with other things, and that's going to be a problem. But for the most part, you make something and then it goes and sits in a landfill. And the circular economy is a huge sort of change in the mindset. And as people start asking nature, especially on the conceptual, how does my organization do whatever, along the lines of forming collaborative relationships, is figuring out how to have that circular economy. And when you're talking about technical materials that you abstracted from the earth, like these rare precious metals, it's really about making sure that those remain in use. Because just because the item goes obsolete from the user doesn't necessarily mean that all the materials or even components that are inside of it are beyond their use life cycle.
Okay, so we've now moved from the nano level, the molecular level, as you said, i.e. nature builds from the bottom up, onto how humans produce man-made materials and how they can mimic naturally occurring materials. How do we translate this, though, into real products and services that could be described more as systems or networks of related products and services, essentially the built environment?
As you know, Owen, I'm super interested in the built environment. That's where, most of my focus lies. I think that there are not only really great ideas that we can take from nature on how to build things better. There are examples of how you can model heating and cooling systems, passive heating and cooling systems after termite mounds, which maintain an even temperature throughout these massive structures. There's also really great ideas around how to build better materials that support, construction materials, whether it's through spider silks or other kinds of plant matter at the molecule level. I think too that the kind of previous point we made about the smartness, the connectedness of buildings, there's a massive opportunity here to study natural networks and figure out how to optimize those, so we're not making things smart in a vacuum, but that we're doing them so that they can have all the necessary sensors and signal management technologies that support really the growth of these buildings and the betterment of all of us. I also really love that there are organizations out there that are incorporating biomimicry into their service product. And I think we are in a service economy. I've also been told that we are in a creator economy where, you are putting out there your service, your offering, and we don't really spend money on major resources anymore, but that we spend money on other people's intelligence. And so I love when I see new organizations, new consultancies pop up that are focused on biomimicry and that they're saying, hey, I can provide you this resource. It's valuable to your specific industry. There's one here in Denver that looks very specifically at the different architectural and engineering opportunities when it comes to building new buildings, how to incorporate biomimicry into those. So that's what really excites me the most.
Yeah, I am along the same lines of thinking as Shana. That's probably why we're friends. But I could talk all day about the why the built environment is just such a rich space to be bringing biomimicry thinking, biomimicry technologies, biomimicry innovation and analogy, design by analogy. All this stuff just works so well in the built environment, probably because of, you want to talk about an analogy, right? So we as in the built environment, we play the role of the builder and the designer and the inhabitant and all of that. all of those sort of things that just humans really love doing. And nature has been doing that for even longer than life. Like the planet Earth has existed making things and structures and taking them down for eons before, the advent of even terrestrial life. So the translation is just so ready there. If you want to talk about how to get our mindset from user, taker, waster, whatever, to creating conditions conducive to life, to enhancing the way that we interact in our environment, then we need to start with the environments that translate immediately to the ones that we are creating, because that's how we practice this. And when you build a house that functions, like a piece, like some sort of structure in nature, like a tree, maybe could be a good analogy. You build a house like a tree, and then you build a neighborhood like a forest, and you build a city like a rainforest, or even ask yourself, in our case here in Colorado, it's like, how would this landscape build that neighborhood and design that city? Like if nature were to make Colorado Springs or Denver, what kind of structures and processes would be in place? And so I think that in the immediate future, we're going to continue to see a lot of expression of biomimicry and biomimetic thinking and technologies, and examples I think really are going to come from the built environment. We used to live in nature as part of an ecosystem, and then we kind of self-elected out of the ecosystem, and then subsequently started, unintentionally destroying the ecosystem, and yet we still have billion-dollar markets formed around, local outdoor places, especially here in Colorado. It's and outdoor activities, because people crave to be in touch with nature.
And how do you see the concepts of biomimicry changing how we develop technology products, or even the way that we interact with technology?
So I think that's a really great question, and there's a few different ways to approach it. I've actually done a few analyses in this area to really lay out how can we take constructs within biomimicry and apply them to existing, templates and formulas for how we develop product and develop business models. And I think outside of having a very specific challenge to solve that you want to bring through the biomimicry thinking process, there's ways to take elements of biomimicry, and there's two buckets here. One is called biomimicry essentials, and they are ethos, reconnect, and emulate. And if you look at those three things, and you look at your business model, or you look at your product development process, and you say, am I adhering to those three things? Am I incorporating ethos, which is really the ethics of our relationship with nature? Am I incorporating the ability to reconnect, which is really, how does this product or business model inspire our relationship to nature? And then last one, am I emulating a natural model? And that one's pretty self-explanatory. The other approach I think that's super valuable from a vetting and measurement and evaluating perspective, and it actually is in the evaluating phase of the biomimicry thinking process, is taking the life's principles. So life's principles, there's 26 of them. There's 6 major ones, and all the other ones are tucked underneath. And they are these universal truths that govern the natural world, and they cover 99% of living things. There are things like being locally attuned and responsive, adapting to changing conditions, evolving to survive. These are fundamental truths that happen every day in our universe. And I've done the analysis to say, how can you apply this to product development processes? And you step by step walk through and say, what do each of these principles mean? How do I interpret them? And then how does that translate to my development process? So an example I'll give you is adapting to changing conditions. Now, this is a life principle that looks at, how do I respond to a disturbance? A disturbance that I like to highlight for folks, super tangible and very relevant to Colorado, is wildfires. This is a disturbance that occurs. It impacts the natural world. So what do you do afterwards? Another one is a supply chain disturbance, like the Suez Canal and all the challenges we're having right now with supply chains. How do you build a product that doesn't rely on a single supply chain or has such a diverse supply chain that you can quickly pivot to get those materials from somewhere else, maybe more locally, that can support your business more quickly? So I think that construct of taking the life's principles and applying it to your existing product development process will yield so many opportunities to reassess how you do things today and build a more naturally aligned product for the future.
What could I add? It was brilliant. Well done, Shana. So if you're an OEM and you're listening to this podcast, you probably have sustainability somewhere in your strategy or in your mission statement or somewhere in your organization, right? Because you're listening to people talk about biomimicry. So probably like the easiest way for you to look at and ask nature for inspiration is to begin with your waste. What are you wasting? Are you wasting materials? Are you wasting energy? Are you wasting heat? And look at those, just start pulling back the layers of the onion on those items and that sort of waste principle in your process, in your manufacturing process. And then start asking, well, how would nature do this? And you might be able to start thinking along into the creative and problem-solving space pretty quickly. And then once you have an idea, then start finding other people interested in biomimicry and start bouncing it off of them and find ways to make it stronger.
Shana and Nick, thank you so much for this fascinating discussion. You broke this down for us and made it all come alive with some really practical examples and ways to get started. I would love to check back in with you guys very soon to dive even deeper and stay in touch with all these exciting projects that I know you're going to be driving forwards.
Thank you.
Yeah, thank you. Thanks for having us. This was fun.
Don't forget to check out harborresearch.com for more insights on smart systems. This podcast was edited and produced by Christy Zoke and moderated by Owen Jennings.
Harbor Research is a growth strategy consulting and venture development firm with over 30 years of experience working with leading manufacturers, service providers, and technology developers to discover, design, and develop smart systems and Internet of Things growth opportunities. Visit harborresearch.com to learn more or follow us wherever you get your podcasts.